The last Java collection we will be looking at is a map, which is a container for unique key value pairs. While a set only stores unique keys, map stores unique key value pairs. This is a mapping from the unique key to the value, where the key must be unique, but the value could be associated with multiple keys. In some programming languages, such as C#, this is called a dictionary rather than a map. Let's see how we can use a map. Assume that this is our initial map where the keys are integers and the values are characters. As you can see, all keys are unique. Now we would like to add the pair 4D, where 4 is the key and D is the value, into this map. Because 4 does not exist as a key in this original map, we could easily add it. So now 4D is part of the map. The map could be ordered. In that case, we call it the tree map because the underlying data structure is a red-black tree. It could be unordered. In that case, the map is using a hash table as the underlying data structure. Here is the Java map inheritance hierarchy. At the top of the hierarchy, we see the map interface that has the following methods: get, given a key, give me the value; put, here is the key, here is the value, just put it into the map; remove, given a key, remove it from the map; contains key, so here's the key, does this key exist within the map; is empty, size, and clear. And HashMap is basically implementing this interface, map interface, through the abstract map base class. But TreeMap implements the additional interfaces sorted map and navigable map, as you see in here. That gives us the additional functionality of asking the first entry within the map, the last entry, the lower entry given a key with the key that comes before it in the ordering, or higher entry, so given a key, that what is the key that follows it in the given ordering. So if we would like to use these additional functionalities, and if ordering is important for us, then we should be using a tree map. Otherwise, if ordering is not important, then we should be using a hash map. Here is how we can create and use a tree map. So we say new tree map. This is a map from integers to characters, and I am using the map interface to refer to the tree map. So I'm putting 1E, 5Z, and 3B. So at this point, because the default ordering of the integers are in ascending order of their values, you can see that all the entries are ordered in ascending order of integers. So 1, 3, and 5. So I'm asking, given the size of this map, there are 3 entries. Now I would like to use the additional functionality provided by TreeMap. To do that, I need to typecast this reference pointer, but it's a map reference pointer right now, to a TreeMap reference pointer. Then I can say, give me the first entry. The first entry here is 1E. The last entry, that would be 5Z. The entry that comes before 3 in the ordering is 1E. And the entry that comes after 3 would be 5Z in the ordering. Finally, if I iterate all the elements of this map, I would be getting all the entries in sorted order of their keys, because this is a tree map. It stores all entries in the ordering that you specify based on the key. Let's look at the actual code. I am creating a tree map. I'm not specifying a lambda comparator to the constructor. That means I want the tree map to use the default ordering of the integers, which is the ascending order of their values. So now I'm putting 4 Alice, 3 Bob, 7 Jill, and so on. Then I would be asking the size of the map, if a certain key exists in the map. Then I'm going to remove a certain key and value pair from the map. Then eventually I'm going to typecast this map pointer, reference pointer, to a tree map reference pointer, and then I'm going to ask, give me the first entry, the last entry, lower entry, and higher entry. So the lower entry, the entry that comes before 3 in the ordering, and the entry that comes after 3 in the ordering. So let me run this thing and look at the output. So here we are. So we are adding 4 Alice, then 3 Bob. As you can see, each time I add a key value pair, they are stored in sorted order, in ascending order of the key value. So this is 3, 4, 3, 4, 7, 1, 3, 4, 7, and 1, 3, 4, 7, and 9. So how many entries do we have? We have 5 entries. Does key 1 exist in the map? Yes. How about 5? No. So as you can see, there is no entry with the key value of 5. So let's now remove the entry that with the key value of 7 from the map. So this will be removed. And now we are left with this one. So let's add to Tom into the map. As you can see, to Tom is now added. So look at this one. If I try to put to Jenny this time, to already exists, but it is mapped to the value of Tom. But I'm adding to Jenny, so that means the key is still will still be there, but it will be updated. The value will be updated to Jenny. So this is different than sets. In sets, you cannot have a duplicate key. We still don't have duplicate keys, but the second duplicate, in a sense, where the key already exists, if the value is different, that will be updated to whatever the new value that you're supplying. So this is an update operation now. And now I am typecasting the reference pointer to a tree map so that I can ask, give me the first entry. And as you can see, first entry is 1 Mary. Give me the last entry, that would be 9 John. And you can see that in here. Give me the entry that comes before key 3, that would be 2 Jenny. And give me the entry that comes after key 3, that would be for Alice. This example is just an modification of the previous example where I am supplying a lambda comparator. So I want the key values, the integer values, to be ordered in descending order of their values. This is what this lambda comparator is saying. So it's exactly the same, except that the keys are now ordered in descending order of their values. So you could see it in here. So the first entry this time is 9 John, and the last entry is 1 Mary. Everything else is pretty much the same, except when we go to the end and ask, give me the first entry, that would be 9 John, and last entry would be 1 Mary. And the entry that comes before 3 in sorted ordering is now for Alice, right? And the entry that comes after 3 Bob would be to Jenny. So bottom line, when you ask these questions, it all depends on the kind of ordering that you define when you create the. As a final example, I am instantiating a hash map and putting 40 Alice, 30 Bob. What you're going to see now is that the keys will not have any particular ordering when I iterate over the entries of the map. And now I also don't have the additional functionality of asking, give me the first entry, the last entry, previous entry, next entry. That is not possible with a hash map because hash map does not store the entries in any particular order. As you can see, this is what happens after I insert, all these entries. You can see that there is no particular ordering of the keys within the hash map, and the update is still there. So after I put 20 Tom, if I do put 20 Jenny, it just updates the value, preserving the key. As a final note, most of the time you would use a simple data type wrapper such as integer, string, character, etc. as the key value in a map. But in case there is an application where you would like to implement a complex class and use it as a key for the map, then you have to override the equals and hash code methods of your class when you want to use them with maps and sets.